What is anti-reflective and self-cleaning coatings in PV modules? AR coating reduce reflection and increase the absorption. Self-cleaning coatings repels dust, dirt, and water, reducing maintenance and preventing the energy loss. Nanotechnology in PV modules. Advanced coating and cleaning solutions. Thin film interface coating. Enhance the light absorption and minimize reflection for higher efficiency. Super hydrophobic nanostructure. Self-cleaning by repelling water and dust. Electrowetting technologies. Dynamic surface cleaning and maintaining efficiency. Thin film interference coatings. Light management. Nanoscale layers optimize light absorption. Reflection reduction. Minimizes light loss for maximum efficiency. Efficiency boost. Enhances solar cell performance and energy output. Durability. Strengthens resistance to environmental factor. How does it work? Sunlight gently passes through transparent and anti-reflective coatings, boosting light absorption. The PN junction separates charges, while the ohmic layer ensures smooth current flow. The substrate, whether flexible or rigid, enhances adaptability, promoting efficiency and cost-effectiveness. Super hydrophobic nanostructures. Self-cleaning, as water rolls off, naturally carrying away dirt and debris. Enhance efficiency, allowing maximum light absorption. Water and dirt resistance. Prevents spots, maintain performance over time. Low maintenance. Reduces cleaning needs and operational costs. How does it work? The solar cell features an HFO2 film with anti-reflective, superhydrophobic, and oleophobic properties. This advanced coating enhances light capture, while the anti-reflective layer minimizes light loss. The superhydrophobic surface repels water, and the oleophobic layer prevents dirt buildup. They reduce maintenance, increase durability, and optimize performance for long-lasting efficiency. Electrowetting-based self-cleaning technologies. Surface control. Modifies wetting properties using an electric field, allowing precise droplet movement. Contact angle reduction. By reducing the contact angle, water spreads more effectively across the surface. Voltage activation. Flattens droplets, enhancing water distribution for better cleaning. Clean efficiency, reducing maintenance, and ensuring long-term performance. How does it work? A special coating repels water, ensuring the surface stays dry and clean. When voltage is applied, water droplets spread, lifting and removing dust and debris. As the voltage turns off, the surface regains its water repellent state, maintaining long-term efficiency. Impact of long-term solar efficiency. Enhanced light absorption reduces reflection losses, maximizing power output. Self-cleaning properties lead to reduced maintenance, lowering operational costs. A longer lifespan ensures protection against environmental wear and tear. And increased energy yield boosts power generation, making solar energy more cost-effective and sustainable. At Green, we lead with sustainable energy solutions that drive progress, foster growth, and enrich lives.